All right, Gabby, I see you started the recording. That must mean it's just about time for us to begin, I guess. It is. It's 1 o'clock. All right, so we'll go ahead. We'll get started. Welcome, everybody, to the webinar today. My name's Ken Walz, welcoming you on behalf of the Center for Renewable Energy Advanced Technological Education. I'm joined today by James Auld from NextEra Energy and my co-PI, Kevin Cooper from Indian River State College. And we're here today to talk a little bit about renewable energy education and how that's playing out amidst the COVID-19 epidemic. Maybe before we get too far into the presentation, we'll say just a few things sort of about how we'll run the show here. Gabby Temple is going to be our moderator today. She will be muting everybody's microphone and the video other than that for the speaker, just so that we don't eat up all our bandwidth and hopefully keeps everything moving a little bit smoother. If you have questions along the way, we'd ask that you type those in the chat box, and Gabby will kind of watch the chat box for us and then interject if there's a good spot to fit those questions in. And we'll also have time for some Q&A at the end of the presentation as well. A few other things to note: this webinar will be recorded, and the recording will be posted on the Create website. So let me just mention that right away, since I know that's a question a number of folks have. The website is createenergy.org. If you haven't been to our website before, we'd invite you to join. You can sign up for our mail list so you get notifications about future programming like this. There's also teaching materials and other things you can access on the website. But if you're looking for the webinars, if you click under the Publications tab there in the middle, and has done over a couple of years. We've been doing several of these this spring in response to the coronavirus epidemic. If you didn't have a chance to go to a few of our more recent webinars, we did one on career mapping for renewable energy careers. We had two guest speakers, Greg Nemeth and Mark Hansen, who spoke on the topic of how solar became cheap and solar schools of the future. And those all might be good resources to download and stream with students or to use if you're teaching online. I'll also just give a plug for our upcoming webinar that'll be in 2 weeks. We'll be working with the group from Purdue University that has developed a virtual wind turbine simulator tool, which again might be a nice resource to use with students. And I know we have Tom Sutton on the talk today. Maybe at the end when we do the Q&A, he might be able to give us a little bit of a sneak preview of that tool, because Tom's been instrumental in the development of that wind turbine simulator. So that's kind of what we have in the way of introductions. Why don't we go ahead, we'll get started here. For initiating the conversation, I thought it'd be useful just to look at some trends in energy consumption. This is a graph of world energy consumption over the last 200 or so years, starting in 1820. And you can see the timeline on the horizontal axis across the bottom and the amount of energy consumed in the vertical axis. And what we observe is this enormous explosion in the amount of energy that humankind consumes that corresponds basically to the Industrial Revolution. And you can see this is fueled primarily by fossil fuels, by coal, oil, and natural gas that you see in the red, the green, and the purple segments on the graph. And of course, this makes possible, huge improvements in our quality of life. It's what allows me to sit here in Wisconsin and eat pineapple for breakfast that comes to us from Hawaii. It allows movement of goods and services. It allows me to live in a nice, warm, comfortable house, even in the Wisconsin winter when it's well below zero up here in the north. But it also comes with trade-offs. All of these fossil fuels, when we burn them, have environmental impacts, which we're not going to go into on this call, but I'm sure everybody is familiar with. So I'm going to show you some other data on energy consumption. It looks very similar to this graph, but it's a little bit different. If we take a look at these plots here, you can see sort of similar types of curves looking at growth of energy. But the energy sources we're looking at here are clean energy sources. We're looking at solar energy, wind energy, and energy storage. The axis on the horizontal scale is also different. This goes from the turn of the century at the year 2000 to today. And what we can see is in the last 2 decades, the last 20 years, we see this massive explosion in these clean energy sources. And those trends are really being fueled at this point now by sheer economics. So this was a headline from last year, 2019, with renewable energy hitting new lows. It's now the cheapest new power option for most of the world. There have been recent analysis that show that somewhere in the neighborhood of about 75% of existing coal-fired power plants could be replaced today by wind or solar at lower costs than what it is to generate electricity from coal. So we're in this sort of once in a generation, once in a millennium environment where we're seeing this massive transition away from fossil fuels towards clean renewable sources. And I thought it'd be interesting just to take a look at a couple examples that kind of illustrate this transition. This is from my school here, Madison College in Madison, Wisconsin. I started working at the school a little bit over 18 years ago. These were the first 2 solar systems that our school installed, a 2.1 and a 1.2 kilowatt system. So you can see the panels look much smaller than what a solar panel looks like today. I can also tell you that the installed cost of these systems came in at about $18 per watt. Now that metric might not mean much to you, but I'll give you a frame of reference for it in just a second. What we're going to do is we're going to fast forward into the future from 2002 to 2020. And here you can see the new solar system that my school commissioned just last year. So the systems we were looking at on the previous page were 2.1 and 1.2 kilowatts. This system is 1,850 kilowatts. It's actually the largest rooftop solar system in the state of Wisconsin. So you're looking at this aerial flyover photo here of our flagship campus in Madison. This system has solar modules, 1,850 DC power optimizers, 53 DC to AC inverters, and all of that system is monitored in real time. So I can sit here at home in my backyard, pull up a dashboard with a SCADA system, and see the output of each individual panel at any given point in time. The other sort of amazing thing about this system, I mentioned that the solar system we installed in 2002 was about $18 per watt installed cost. This system came in at under $1.70 per watt installed cost. So over the course of less than 20 years, we saw more than a 90% reduction happened in the wind sector to make those 2 technologies now sort of the go-to technology for electric production. In addition to the economics, there's also some policy drivers that have been happening at the same time. This is an older headline from 2017 from when Madison, Wisconsin committed to a 100% renewable energy pledge. That was the Madison City Council took up a local resolution to transition the city to 100% renewable energy. That was kind of a unique thing at a time. There was maybe a dozen cities around the U.S. that were kind of on the leading edge of that curve, but we're no longer unique. This list now includes over 130 cities and 8 U.S. states that have passed similar legislation to transition to 100% renewable energy. So it's pretty clear where this trend is headed. And wherever you live in the U.S., there's almost certainly some jurisdiction nearby that is working on a transition plan to clean energy. Of course, all that activity means that there's a workforce need as well. So this is some data from the Bureau of Labor Statistics that just came out this past fall, looking at the growth rate of different occupations in America. And the 2 fastest growing occupations were solar photovoltaic and wind turbine technicians that you can see in the green bars there in the middle of the screen near the bottom. You know, when we think about fast-growing occupations, people oftentimes think about healthcare and the tech services, the IT industry, and those industries certainly are growing fast. You can see healthcare jobs listed here, but the energy industry, the clean energy industry, outpaces both of them considerably, almost by twice as much. I think it's also important to note, if you look at the salary statistics there, that these are good-paying, family-supporting jobs. And some things that, you know, are attractive to our students, these are jobs that are not going to be outsourced, and they can't really be done by robots. You'd be hard pressed to design a robot that could climb up a wind tower and get up on top of the nacelle of a turbine. And they're also jobs that you can look yourself in the mirror at the end of the day and know you've done something to benefit society and feel good about the work that you do. So all of that's kind of what's driving the workforce and what's motivating colleges like ours to educate students for these careers. So what about the coronavirus? I think everybody is aware that we're in a bit of an economic slowdown right now, and that there's been a lot of displaced workers in the last few months. So if we look at the energy industry in general is considered essential critical infrastructure, which means that people employed in this industry have continued to work even amidst social distancing requirements and safer at home ordinances. These are sectors that still need to continue to work, and we need to continue to have for our emergency response systems. And that includes both wind and solar and other types of electrical generation as well, hydropower and biomass, and any part of the electrical grid is still part of this essential infrastructure. There have been some job losses, as you might imagine. Certainly some of the solar installation industry is not as fast as it was a year ago this time. This was a headline from just this past month, April. There were about 100,000 workers in the clean energy sector that lost their jobs in the months of February and March. Just to put that in perspective, that's roughly about the number of new jobs that had been created in 2019. So the coronavirus epidemic has basically set us back about a year, sort of resetting to where we were 12 months ago. Folks have also been, a lot of different people have been trying to look at projections of what might happen depending on how this epidemic proceeds over the year. That is a hard thing to project. People can't really project how long the shutdowns might last. It's hard to predict how fast the epidemic might grow when we might have a vaccine. There have been some projections that predict more job losses, but at the same time, there are other segments of the industry that continue to grow. And there's been at least a few studies that have suggested that this might be the sector that bounces back the fastest. Because clean energy was the fastest growing I'm sorry there, my dog started typing on my computer. I apologize. I lost my train of thought there. Because this sector was the fastest growing before the coronavirus epidemic hit, it also may be the fastest growing sector to rebound. James will talk a little bit more about this from NextEra's perspective in a little bit, but I can tell you that the employment is different depending on the regions of the U.S. where you are. It's also different depending on the scale of projects you're looking at, whether they're utility scale solar farms or residential scale construction. For a little bit of just anecdotal evidence here in Wisconsin, we have a NextEra Energy solar farm, 100 megawatt farm that is still going according to project schedule from what I'm aware of up here. We have another 150 megawatt solar farm that was supposed to be happening just a little bit west of my campus, and that project is delayed by 6 months because there wasn't enough hotel housing for the workers available to bring workers in. It's in a small rural area, so they had to bring workers from neighboring parts of the state, and there was no place for them to stay, so they had to postpone construction at that site. So I think anything we observe in the industry is going to have those sorts of uneven patchiness characteristics to it, depending on where you're located. For folks that might be students thinking about going to work in this industry, the clean energy industry needs all kinds of science, technology, engineering, and math professionals. Engineers of all flavors, but in particular civil, mechanical, electrical, environmental, and geological are the main ones employed in the industry. Of course, electrical technicians and architecture and construction technicians are essential workers for this industry, as well as project managers, construction managers, and energy analysts. So that was the sort of backdrop that I had put together for folks. Gabby, this might be a good spot for us to just pause and ask if there's any questions that came across on the chat board. I think you've been monitoring that.
So far, I don't have anything in the chat box.
Okay, well, then I can yield to James. James, are you able to screen share your own slides, or would you like us to drive them for you?
Here, let me get down to James so I can unmute him.
Okay. I do have James' slides, so I can put them up if he needs us to.
Okay. I can make him, I've made him a co-host. Okay, I've made him a co-host.
James, you still got audio?
Let's see. You there, James?
I'm here, but you're going to have to let me have access through the phone.
There, you do now.
Okay. Can you hear me?
Yep, we can hear you.
James.
Okay. Okay.
I can drive your slides for you if you just want to let me know when you advance them.
Yeah, I will say click at the appropriate time. How's that?
Okay.
Okay. So I'm James Auld. I'm the Director of External Training with NextEra Energy. So click. Can you click? Do you hear me? There we go. All right. We are the largest producer of renewable energy in the world. And my intent of this isn't to be a commercial announcement for NextEra by any means, but just so that you have a perspective of who we are. Click. And that's just a little bit of some fun facts about us. We are all in, and we are making significant investments in energy infrastructure, and particularly on the renewable energy side. Click. All right, so what is our challenge? The challenge is, where are we going to find the next generation of highly skilled and well-educated energy professionals? And so let's kind of put this into perspective, how challenging this is, and I'm going to use the wind as a compass point. Back when we first got into wind energy about 25 years ago, wind turbines were big mechanical things on a stick. And we would go to the Jiffy Lube and the Pet Boys, and we would dangle a few more dollars in front of the technicians to come and change the oil in our gearboxes as opposed to the oil in automobiles. And that was sort of the skill set back then that was required. But fast forwarding to today, wind turbines are complex power plants on top of a stick, requiring extensive skills and instrumentation and controls, electrical, mechanical, networking, all sorts of things. So we really determined that what we needed to do was build robust talent pipelines with strategic partners, including our college partners. And and CREATE has been wonderful in helping, particularly on the solar side and connecting dots. But one of my good friends that's on the line, and I'm going to be tapping his expertise a bit through my presentation, Tom Sutton with Kalamazoo, who runs a top shelf wind energy program in Kalamazoo, Michigan. And you know what they say about Kalamazoo: all your dreams can come true in Kalamazoo. So click. All right, so click again, please. Okay, so these are just a couple of the areas involved in renewable energy. There's so many more that I didn't include because I wanted to keep this presentation under 7 hours. We have in other areas too. We have development. There's a whole bunch of environmental issues side of the house, environmental sciences, and the whole sticking your finger into the wind and knowing which way the wind blows on wind, and which, where is it sunny, and all of that kind of stuff that goes into the whole development side of it. But I was going to try to stick more on the technician side of it, and then talk just a little bit about what we're doing to continue training in this current environment. So click. All right, so let's start with the data analytics. And I'm going to tell you something. About 4 years ago, 5 years ago probably it was, I was at Texas Tech with some of our control center folks. And one of them said to me, Jim, when you're working with colleges and universities, you need to emphasize the importance of SCADA. And I said, I'm certain that's certainly a great idea, and I'll certainly do that. But first, you have to explain to me what SCADA is. And he gave me supervisory controls, data analytics for dummies. And I'm pleased to report now that I have certainly a fundamental understanding of this. And with the help of Create, we're actually developing a platform for SCADA, whereby colleges across the country will have access to data points coming from across the country, and it'll really help drive in this area. But I was recently at a conference, and one of our executives, he said, if you're ever asked, what career could take me from beginning to retirement? And the answer was data analytics. With data analytics, we're doing just amazing stuff. It's allowed us to move from, what was time-based maintenance. Oh, it's June, it must be time to change the oil in our gearbox. The condition-based maintenance, and now we change the oil when the condition says it needs to be changed. So for example, a foreign material in the oil, breaking down viscosity or what have you. To now we're getting into predictive analytics. So how long can we actually run the turbine in that current state? And then we can, with that data, we're able to make wise decisions of where to move our technicians and when to schedule things and all that. So data analytics is a hot spot, everybody. Click. All right, so here, so we have, you'll notice the 100+, because every time I give a presentation, and I would use this slide, if I were to commit to a number, somebody from NextEra would say, the number's actually this, it's actually that. So the number's closer to 200 than it is 100, but it's constantly changing. We control an entire fleet across North America from our headquarters in Juno Beach, Florida. And what we're in that bottom right corner is the control center. That's the old one. I need to bring in the new picture. The rock it's much more impressive than this. Some of you are actually in our rock when we had a meeting in Juno Beach in January. So click. Okay, so here we are, sort of a day in the life of a technician. And this is where I thought I would take a pause and let my distinguished colleague, Tom Seton, kind of walk us around this and talk about what's going on in the day in the life of a technician. Tom, are you able to jump in here?
Sure. Can everybody kind of hear me? Excellent. In the top left, what we see happening here is the technician is using a tool that tightens or torques the bolts to a very precise specification, and this is on the blade to the hub connection through the blade bearing. The top center picture is inside the nacelle, and this is back closer to the generator, kind of between the generator gearbox. The gearbox is closest to us in the picture. And I can't really tell what he's doing in there, but typically the technicians would be inside there doing different maintenance checks, perhaps even using SCADA within the nacelle to help control certain aspects of the machine while they do maintenance. Top right picture kind of speaks for itself, the view out over a typical wind farm. We move to the lower left. This is what we would call a major component corrective or a major component replacement. They've got a crane you can see in the red there, and they're connected to a gearbox, and they're getting ready to either lift that out or they're putting it in. Lower center, this is a technician doing what we call the crossover or the jump. This is a turbine that actually has a hub entrance on the outside. So they go up on the roof and cross over or jump up to the hub using an outdoor type approach. And then again in the lower right is another technician tightening the blade bolts out on the hub.
Thanks, Tom. Appreciate that. Next slide, please. Here
we have in the top left what we call a rotor lift. or a drop, and it depends on which direction it's going, up or down. So lift would be up and a drop would be in the down direction. Many times to do a large drivetrain correction or during construction, we'll lift the rotor in its entirety with all three blades connected. Top center, we have two technicians that are on the end of the blade tip. They're using rope access. Looks like they're probably doing some blade type repair, some fiberglass work, and so on. Top right, we have a beautiful nighttime shot. This is probably a construction site. It's a lot of times with the wind will be a lot lower in velocity at night, and we can lift these components much safer within our parameters. The lower left, we have a gearbox connected with what we call spreader bars. Those are the yellow things. And then all the rigging is the chains and everything to make it adjustable. This is a gearbox that's either coming out or going in. And in the lower center, it's the same thing, but you can clearly see that the top of the nacelle has been taken off, and the gearbox is that blue component that's suspended by a very unique crane in this picture. This crane is a crane that attaches and is built upstairs. It's not like the typical crane that we might see on a crawler crane or such like that. And then in the lower right is kind of a size perspective. That is the hub and the blade root connection in comparison to the 5 technicians standing just in front of it.
Okay, next slide, please.
You want me to go on this one?
Well, I don't see it yet. I'm waiting. There we go. Okay. Yep. I'll take this one for a second. All right. So,
Perfect.
You know, our being the largest producer of renewable energy in the world, we have we're in a unique position to have a treasure trove of experts that work for us. And one of the things that we found was we were having challenges with the cranes. Because where wind turbines are typically found, well, will be found, are in windy areas, right? Common sense. Well, as you can imagine, building these sites presents and maintaining them can be a challenge to get days that are actually calm enough where you can do crane work. And that downtime was actually driving us nuts. So we actually developed, patented, and we implemented our own crane system. I call it King Kong. I'm the only person in our company that calls it King Kong because it's easy for me to reference that. It sort of goes up the turbine tube, and then with this articulating arm, it's able to drop in that area. And the reason I'm talking about this is when students are thinking about renewable energy in the careers, this is an area that's very exciting to students. Learning about the crane operations and all of the calculus that's involved in it. It's just exciting stuff to see. So it's another career opportunity or a subject matter expertise engaged within the wind technician career opportunities. So click next one, please. Okay, so yeah, we do have some assembly required, as I was mentioning earlier, one of the challenges of building these sites can be the wind. I was actually in North Dakota, waiting by a site, waiting for the winds to die down enough so they could do some of this, and it was at night, like Tom mentioned earlier, and then the lights clicked on, and all of a sudden, all this action started, and it was really cool to see. So yeah, so you can see the career opportunities are far broader than just simply maintaining the turbine. There's the building and then all these extra cool things like crane operation. So click. Okay, so that's just another perspective. And I mentioned earlier, you know, the skill sets are certainly critical and important. This would be a good example. You certainly wouldn't want an unskilled person dropping that very expensive piece of equipment into that eggshell turbine, or nacelle is what they're called. Click. All right, so Dr. Walz, he did a great job going over some of the fundamentals of solar, but I have a couple slides I'll share with you, and I certainly won't dive into them as deep as our good Dr. Walz would. So, you know, solar, it's the photovoltaic energy is to me is magic, right? You point this thing at the sun, and out the other side comes electricity. So how's that for a good scientific explanation of it? It starts off in DC power, and then we have to invert it into AC power. So, for you academics out there, what a great opportunity to talk about the thought pattern between Tesla and Thomas Edison. And wouldn't it be cool just to bring them back for one day and have the conversation of who was right and so forth, or maybe they were both right with the current state. Click. So you get this, right? You're all academics. It's a remarkable phenomenon, and we do talk much more nowadays about photovoltaic, which is the direct conversion of the sun's radiation energy into power. There's also another form called solar thermal. NextEra actually has the first hybrid plant of its kind in the world. It's called our Martin plant, where during the day we heat the water that makes the steam that turns the turbines with the sun, and then so we're able to take the throttle off the gas pedal, if you will, during the day, and then we avoid having to use natural gas to heat the water. And this is a combined cycle plant, so this makes it really state-of-the-art. Combined cycle means that you reclaim the energy that goes up in steam and use it again, and it's something known as a HRSG. I won't get into the science of all of that because I don't want Dr. Walz to start laughing at me. So anyway, click. So here, and Ken talked about the sort of the spread earlier. But as you can see there, this sort of shows us where the sun shines. In it, I can tell you that it's remarkable where we are talking about developing solar today. And the conversations wouldn't even have taken place even 5-10 years ago. Areas that are cold in the winter, snowy, short days, overcast, they wouldn't be good candidates for solar. But frankly, just about anywhere is a candidate now for solar, because of the efficiency. And where will we be in 5-10 years? It just gets more and more exciting. Click. So here's a really cool phenomenon that we're seeing, and it's storage. So imagine with me, if you will, a technician, the technician of the future that has skills in wind, solar, and storage. We really see this as being the future, where trifectas, if you will. And so as our programs expand and develop, we really see, more of a universal technician. I've watched this happen in the nuclear world and in the fossil side of the house. When I started, and it wasn't that long ago, less than 15 years ago, we really had these swim lanes. We had instrumentation and controls, we had electrical, we had mechanical, and so forth. But over time, I've really watched these roles merge into more of a mechatronics phenomenon, and I'm certainly seeing that. For example, we have what we call shift techs, and they are these multidisciplined subject matter experts working in state-of-the-art fossil plants, and we see that trend will be happening with the renewable energy technicians, if you will, where they're going to be multi-skilled. So click. Okay, so here's just a snapshot of where you can get information about applying for jobs and so forth with NextEra. But anyway, so back to the point. We're talking about the COVID virus and how it's impacted our training. Well, we are part of the critical infrastructure in the energy sector, right? So our power plants are continue to operate. We're continuing to make electricity and so forth. I'm not considered critical to that, so I work from home right now. But I can tell you that we are continuing to hire technicians. The demand remains in place. So here's how we would typically train to ramp up the sort of the start to productive work. we would typically hire folks out of our talent pipelines, for example, Kalamazoo Valley Community College. Then that person would report to the site that they're going to be working at. They would do a prescribed amount of computer-based training, and then some on-site training, and then they would go to Iowa, where we have our Iowa training facility, and they would go through what's collectively known sort of as a boot camp, where it's a immersion into our safety culture and all of the things to necessary to get them to productive work. So what's changed in the coronavirus environment is that training part of it that takes place in Iowa. So what we're doing is we're continuing to bring the folks on, but we're doing, the most of the training right at the sites. This keeps the numbers small, and the sites are in remote areas to begin with. So where the social distancing and so forth is already sort of exists at the sites. The challenge for us though is, and it goes to the advantage of the Iowa training facility. When we train at the site, we have to take our best people out of production to do that training, and we have to take our equipment out of productive use for that training. So that's been that's a challenge in this, for the continue the training. But this, as we know, isn't a permanent thing, and we'll get back to our Iowa training facility. From the talent acquisition side of the house, it has certainly changed what we do, and it has certainly changed what I do. So we're doing, everything in that virtual type of world now, interviewing and so forth, and doing presentations at schools virtually. And not too long ago, we did one of these at Kalamazoo Valley Community College, and it was real challenging for me because when I talk, I like to walk around and be theatrical and so forth. So for me to stay behind that camera, I really felt like I was in confined space, and I frankly found myself uncomfortable in that environment. But then I thought about how that must be for the students that are being interviewed in that space. And, so I've been, and our recruiters have been cautioning, the site managers and so forth, the hiring managers, that this interviewing in virtual space can be in of itself a very nerve-wracking experience. So we're all learning and adjusting in that process. So that's kind of how we've been doing it. Let's see. Yeah, I think, did I hit all that? Yep. So that's kind of it in a nutshell. We're continuing to move on. We got, people expect to be able to plug something in, and there's electricity coming out the other end. So we're continuing to do it. So with that, I'll turn it back and answer any questions that you may have.
Okay, so we do have two questions. One of them, all right, so for the data analytics or the SCADA, and Jim, this may be a you question, or it may be a Kevin, Ben, or even Ken question. What 2-year or 4-year program courses would you offer that supports development of relevant skills? So I'm not sure on the team who would like to answer that question.
I think, Ken, this might be a good opportunity for you to give an overview of what it is that's being built with Create Support.
Thanks, James. I was starting to speak there and then realized I was still muted on the mic.
Yeah, I think most of the team is.
Let me see if I can. You guys can hear me now?
Yeah.
Okay, very good. I might be able to turn my camera back on too. I don't know why that's not coming back on, but anyways, what James is alluding to is Create has a current grant from the National Science Foundation to address SCADA control systems and data acquisition systems. This is a project that just started last year, and we have a group of about 20 colleges that participated in a workshop in January to start fleshing out that process. basically, to give you a thumbnail sketch of what that project entails, we've put together a job task analysis to first look at the skills that are necessary for technicians working in SCADA technology. We're now in the second part of that process, which is to take that job task analysis and translate it into some curriculum for instructors. So Kevin Cooper, my co-PI down at Indian River State College, has a couple SCADA experts working on that curriculum, which we hope to be able to unveil to the public yet later this year, along with the JTA. The job task analysis is currently being vetted by folks from industry to sort of go through the original draft and verify and validate that document. And then in the upcoming years of that project, we'll have some train the trainers programming for instructors as well. The other piece of that project that's very unique is the development of a open source SCADA platform that can be shared amongst colleges. And maybe I'll just invite Kevin, if you want to describe that a little bit, since it's your staff person, Chris, who's been sort of spearheading that effort.
Sure. Thanks, Ken. I'll add my video to it as well. We're wearing matching blue today, Ken.
Yeah.
Our skies are not as clear, though. I know yours is a virtual image since we have a storm brewing in the Atlantic right off coast right now. So for very early season hurricane.
Yeah, this should not be hurricane season yet, I wouldn't think.
Yeah, it's very early season one, way early for the season. But long story short, on the SCADA platform, it's an open source platform, as Ken said, where if your system is collecting data that is transferable via the web, via Bluetooth, via 101 different mods, that we could integrate it, and then folks from around the world can look at the data. I mean, in a typical solar platform, there's not a whole heck of a lot of data, so it's a really good example of using data analytics with a limited data set. I mean, you can have tons and tons of panels, and each one giving a voltage and a current and and inverters, but there's not a whole lot of devices. So it's a really good entry-level data set for a technician to learn on. And it also embeds some simulations where you can embed simulated solar fields. So you can get the idea of how the data is collected and then how you would manipulate it. Does that answer your question, Ken?
It wasn't my question. It was from somebody in the audience. But yeah, that's a good description.
But one other thing I would add to the whole thing is that part of that question, I believe, was how to embed in 2- and 4-year programs. We have a standalone SCADA course in our engineering technology 2-year degree that matches learning outcomes of electrical technician. But the way we're building the curriculum is it's very modular based. So you can take one or all the modules to create a full course, or just take the introduction module and put it into any course you like. And actually that introductory module is done and ready for review from a bunch of folks. So the more that would like to review it, the better.
That also reminds me, Kevin, we maybe should mention that one of the consultants working on the project is Chris Akelian from San Luis Obispo, California at Cuesta College. He's working on developing sort of 2 parallel sets of lab activities with regard to data. One of which would mainly focus on the data analytics, and then the other one adds in PLCs and controls. So there's sort of 2 levels of technology there, depending on the program that you're trying to integrate this into. And we hope to have those lab activities developed in year 2 of this grant project as well. So stay tuned on that. If you subscribe to the Create email list in our newsletter, you'll get more information about that as it becomes available.
And then the follow-up question was if the course material is publicly available, and I can answer that. So when it's complete, yes, it will be publicly available. But it's not done yet.
All of Create's content is published on an open source Creative Commons license. So when we do release that, it'll be available for free, and you can modify, edit, download, adapt to meet your needs.
Yeah. And then we have a question here that is for Jim, and it's a 2-part question. And it's, does NextEra build and operate renewable power facilities? And then the second part is, with lower power demand, are we seeing renewable systems being among the first or last to be dropped from MISO dispatch?
Okay, so
That's the
I
MISO
object
dispatch.
to-
They're asking about the Midwest Independent System Operator dispatch.
Yeah, thanks. I was going to object to the multiple questions. The lawyer in me was going to come out. So let's take them one at a time.
Sorry about that.
Because I could guarantee you I won't remember the second one somewhere in while answering the first one. So, and in fact, having said that, now I don't remember what the first one was. So what was the first question again?
I'll answer that for you, James. Yes, you do build and operate renewable.
Oh, Ken. Yeah. Thanks,
You're building
Ken.
one in my state.
Yeah. Oh, yeah. So it's it's an OM question. Yeah. All right. So yeah, we operate and maintain our facilities. We do not build them. We're not in the business. We're not a construction company. We're what our commodity is electricity. So we operate, we maintain. What we do is we work with what are known as EPCs, engineering procurement contractors. But having said that, we are absolutely joined at the hip into that process. We have a whole team that's involved in the construction side and so forth. And then once these things are built, we're deeply involved in making things better. For example, going back to that crane that we talked about, we're always looking at ways to build a better mousetrap and so forth. But so that sort of answers that question. And then the second part, had to do with, what was it, the Minnesota? What's the second question?
Oh, it was about as the demand for electricity is sort of contracted with respect to the virus. What plants or what generating assets are the ones that have been coming offline? Has it been coal plants that are taken offline, or is it natural gas because it's flexible and easy to turn on or off, or are we seeing renewables being curtailed? They were asking specifically about the Midwest Independent System Operator, but I think you could probably answer for any part of the grid network.
Yeah, right. So it's what you want to do is you start, the compass point is what's the most difficult to throttle up and throttle down. So the most difficult to throttle down is nuclear. So you want to try to keep your nuclear power plants running at 100% capacity whenever possible. Then you go down the line. What's most cost effective to throttle up and throttle down? So and this is where storage becomes such an important factor in all this. So with storage, you can store the power and it acts as a capacitor on the grid, and then which helps regulate against rollouts and blackouts and all that good stuff. So it's interesting how electricity is bought and sold. It's very much like stocks, right? So it's all supply and demand. You can't overload and you don't want to underload. So so wise decisions are being made. So you sort of roll down what's the most cost-effective way of maintaining grid integrity. And now that renewable energy is so competitive, and it's clean and it's efficient and it's easy to maintain. Those are one of those ones you'd rather keep going, and then you'd prefer to throttle down the natural gas and clearly coal if you can. But it really does become a dollar cents to equation as what is the cost of restarting, repowering, and so forth. So there's a lot of issues that are involved in that. But it's interesting though, some of the easiest to control in that space are your renewable energy. If you need to down power, it's easy to reduce production at a wind site. Use your SCADA, just trip X amount of wind turbines. I'm often asked, how come when I drive by a wind farm, half of the turbines aren't spinning? Apparently they break a lot. And then the response to that is, no, they don't break a lot. It's all based on supply and demand. You just happen to be able to visualize that. Unlike a coal plant or a natural gas plant, you can't see how much power they're producing, but it's easy to visualize a solar or a wind site. You can't visualize a solar field. There's no way to know how much power just looking at it, what's being produced. So I don't know if I'm answering your question or rambling in circles, but there's a whole strategy, and very smart people do that analysis as to what comes off first and what stays on. And I can tell you this, with a nuclear fleet, that's the one you want to try to keep constant. Did that answer the question?
Yeah, thanks, James. That was great. Gabby, did we have any other questions that we needed to follow up on at all?
So we do have one more, and it's actually for you, Ken, regarding your campus system.
Okay.
It says, for the large campus PV system, did you include battery energy storage? Have you evaluated the effective cost of energy as kilowatts, and how does that compare to the grid electricity effective cost?
Yeah, so that's another two-part question. We often get the question about the cost. I can tell you for our system, the levelized cost of electricity for us with that solar system is about 4 cents a kilowatt hour. We pay retail rate a little bit over 10 cents a kilowatt hour. So the solar is producing energy for us at less than half of what it would cost us to buy from the utility. The question about energy storage is one we get asked all the time. Much like most other technical colleges, we do teach night school, and obviously the solar system doesn't generate for us at night. We have done a feasibility analysis to look at energy storage, and it may make sense for us in the future, but I can tell you right now, the most cost-effective thing for us to do is just to put more solar on our other campuses. My school operates buildings, 20-some buildings at 13 different locations. So we actually have an RFP on the street right now to add solar to 2 more of our campuses. We just closed on that RFP yesterday, and we're evaluating proposals for those projects as we speak. But I like this question. I'm glad you saved it till now, Gabby, because where we are looking at the battery storage is in the future replacing some of our backup generators for emergency power at our campuses. When those generators reach the end of their service life, rather than replacing them with another diesel generator, it's pretty likely that we will be looking at battery energy storage at that point. And maybe what I'd like to do is ask Kevin to chime in here, because I know he's creating a new program at their campus to look at the sort of interconnection between solar and storage and energy resiliency. And I know there's some other folks on the call that are also either creating new programs or designing new programs. And maybe, Kevin, you could tell us a little bit about what you guys are doing down in Florida and sort of what you guys have coming up for the next school year.
So there's 2 things I want to, can you hear me okay, Ken?
Yes.
There's 2 things I want to echo what Ken said. That's super important for the university and college system. Specifically in Florida, operating budgets are going down every single year. But they're giving us a lot of funds from grants or one-time capital purchases to buy stuff. So the idea of adding solar like Ken did is a genius idea, because it lowers your operating costs and you can use that one-time funds. So I really recommend every school look into what Ken did. It's a genius way to navigate when operation costs go down and other money's available. So I want to put that out there. And then 2, you know, Florida is, I believe, 40% of our economy or more is hospitality related. And so over the last year, we've been looking at, or not even since COVID, let's just go with, looking at how we can get hospitality people that may not go back to work. And solar, HVAC, electrical, battery systems, and what's it called? Construction are about the easiest ways to get them back to work. So we've just recently received a large grant to do solar training to get some people back to work in solar. Don't let me forget fiber. Fiber's another one. We did and I know it's off topic, but anybody who is older and can't work in the field, all the schools on the line should really look into quality assurance for computer code. It doesn't take understanding code, you're just testing code. You don't have to work hands-on, and there's a ton of quality assurance jobs out there right now. So quick programs to get people back. But on a side note, and both Jim mentioned it and Ken mentioned it, the idea of getting people back to work, and specifically people of lower income or people in the hospitality or people with limited skills, solar was a very important way. And we had to design something solar-wise to get a result right away. So what we designed, and if I can share my screen for 2 seconds, I think I can. I'm not skilled enough to share my screen, but
give me a second, Kevin, and I'll make you a co-host.
okay. So, and just like Jim said, the turbines, I'm a co-host now.
You are a co-host now.
Okay. Share screen. You should be able to see my screen now. Is that true? Can you see my screen?
Yeah, it says it's launching. Yeah,
Okay.
There you go. You got it.
So, real fast, because Jim said that when you see a blade spin, you know it's creating electricity. It's very visual. When you're working with young kids that need jobs, they get excited about visual. And one thing we actually just created on a new grant we launched was just a tiny generator, which is just a panel that pops open a marine battery and an inverter with the charge controller in the back of the panel. And for $500, we can create these tiny things for hurricane season, as I was talking earlier about hurricane season, where you can keep your refrigerator powered. And the kids love it, and then the counties love it as well. So when we just launched this new training program, it actually scaled into something where we can create these for the county, and they're gonna buy a couple hundred for low-income housing. So the kids are actually making something that's going into the homes. And Ken, by the way, we're gonna hook this up to the SCADA systems as well that we're talking about. So
yeah, that's very cool. I'll be eager to see the data when they start generating.
Yeah, so that's the whole gist of what we're doing on the side. Real fast training, no more than 4 weeks, getting people back to work in fields that they can get jobs without having strong technical skills. And solar's definitely one of them. And I'm not sure I know how to stop sharing my screens. Oh, right here. So back to you, Ken.
Did we have any more questions from the audience, Gabby?
I have one more follow-up question for you, Ken, and it's they want to know what incentives or grants did you use to get your kilowatt hours
to get our solar system installed?
Yeah.
So for the large system that we installed last year, we had a $500,000 grant from our local utility and the EPA. So that covered about 20% of the cost of that system. For the two systems that we're installing right now, we have, again, a grant from a local utility. We have a grant from what's called Focus on Energy here in Wisconsin. That's a state public benefits program that's paid for out of utility revenues. And then we received a panel donation grant from a philanthropic foundation called the Solar on Schools program that donated 100 kilowatts worth of panels to that program. So we've used a mixture of finances from different sources to execute these projects. But I would say no matter where you are located, there is probably some grant money that you can go after, as Kevin alluded to, where you can find a source of funds. It probably won't pay for the project in full, but you know, you could probably, I would say, figure you can target somewhere between 20%, maybe a third of your cost that you can make up with grant revenue. And then the other thing we did is we accessed our capital budget. Much like Kevin was describing in Florida, our operating budget is we have a deficit in our operating budget every year from one year to the next, but we do have access to capital funds. So if we can borrow money out of the capital budget at a very low interest rate right now, it allows us to sort of pay forward our utility costs and help control our operating costs for 20, 30 years in the future.
And we had one last question. It was for Kevin. He's actually answering it on the chat box himself, but it had if he had additional training or project development for the Hurricane Battery Solar Kit. And he does have specs. It's a brand new project, so he's letting people email me, and he's provided his email address in the chat box for anyone who would like it, and he'll send them what they have. So.
Excellent. Well, I see we're almost at the end of our time, but before we sign off, I would just mention again that our next webinar is going to be with some folks from Purdue University who will be speaking about a virtual wind turbine simulator tool that has been developed. And Tom Sutton, who I think is still on the call with us here today, has been piloting that. Tom, would you like to just say a few words about the virtual wind turbine simulator?
Sure, real quick. It started as a safety simulator, a way to get technicians to react in a virtual world and think about how to climb a turbine safely. It has morphed into a much more broad overall application. So now we have the whole turbine with the ability to do virtual troubleshooting on the pitch systems, Instructors can create their own electronic faults in the virtual world, and the students work through SCADA to do remote troubleshooting and kind of come up with the tests that they're going to need to do once they're upstairs. And of course, all the safety and the protocol works itself into the simulator also. It has the ability to measure their performance both in time-based and correctness. And we're hoping that it will help those schools that don't have access into actual operating machines to introduce their students to that world.
Well, Tom, I can tell you I had a chance to demo out the system this past October at the National Science Foundation Advanced Tech Ed Conference, and it was really pretty impressive, and I think it'll be a great tool for everybody who's looking at teaching either online or in a hybrid format this coming school year. So we're really looking forward to that webinar coming up in 2 weeks. And I'll invite everybody that's on the call or watching this as a recording to join us and to check out the createenergy.org website, where you can sign up for our newsletter and for our email list to get updates on future programs. Thank you, everybody, for tuning in this afternoon. And most importantly, just wish everybody a good weekend and stay healthy for everyone and their families.
Yeah. All right. Thanks, everybody.
Thank you very much, everybody. Good stuff.
Good stuff.
Thank
Thanks.
you.
Bye.
Bye-bye.
Bye-bye.